Hey everyone, let's continue with 2.3. This is page 28, and on this page we talk about the shapes of distributions and how they relate to mean, median, and mode. So we'll look at a few types. The first one is symmetric. Right? So a symmetric distribution, it's just, if you do a vertical line, the both sides are mirror images of each other. And we'll look at some examples in a minute, right? And in a symmetric distribution, mean, median, mode, all equal. Okay. Another one is called uniform. Uniform is when all entries or classes in the distribution have approximately equal frequencies, right? So, like if you think about a histogram, all the bars are the same height. And then the uniform distribution, mean and median, are equal. And then we get to some that are called skewed. Skewed is when there's a tail that elongates more on one side than the other, right? So if you have a skewed left frequency, the tail extends towards the left. So the tail to the left, right? We'll see some pictures in a minute. And in those cases, the mean is actually less than the median. We'll see why when we look at it here shortly. And then a skewed right is just the opposite. Okay, skewed right, mean is greater than the median. So let's look at the pictures of them. Okay, so we have symmetric, right? So if you just think of that as a line down the middle, let me do that in red. Right. If you have a line down the middle, it's symmetric mirror images on left and right, right? Whereas uniform, they're all about the same height. Uniform is also symmetric, but it's more specific that it's all the same height as well. Whereas then in skewed left, notice here we have, so the tail is to the left, right? It's kind of tailing off with those smaller bars, which means you might have some outliers towards the left, and those tail outliers are going to pull the mean towards them, right? So that's why here the mean is closer to the tail, right? Same if it's skewed right, the tail's on the right, the mean is closer to the tail, right? So the mean gets pulled towards the tail where there might be some outliers. Okay, so just a couple of questions about that. Determine the approximate shape of the distribution. Okay, let's see, what do you think about that number 5? So number 5 looks like we're getting a tail, right? We got a tail to the right. So again, to get the tail left, tail right thing correct, just look at where the tail is going, right? So that would be a skewed right. This would be A. Right? How about 6? Okay, 6 I would say is approximately symmetric. Okay, it's not going to always be exactly symmetric, but we're looking for approximations here. And so I would say, we have some symmetry on the left and the right, so that would be D, right? Okay, so symmetric. Here we have a skewed left, tail to the left, right? So which one is skewed left? That's C. Here we pretty much have the bars all the same height. Again, not exactly, but approximately. So that's B, uniform. Okay, and then those are our 4 main types that we're concerned with. Okay, list the number of the above graph that matches the description. All right, so can we relate any of these to real world data? So let's see if I put them all at the same time here. List the number. Okay, so how about 180 rolls of a 12-sided die? You would probably expect you'd get the same number of each side, right, if it's a fair die. So I would expect, we have 12 numbers here, right? So it looks like that would be number 8. How about mileage of service vehicles at a business where a few vehicles have much higher mileages than the majority, right? So a few vehicles that have much higher, that would be like a tail to the right, right? Smaller bars is a few, and they're higher, so that's to the right. So that'd be 5. A score on a 90-point test with a few students scored much lower than many of the students. Let's see, that would probably be number 7, right? That represents that left tail. A few students, smaller bars, scored lower, a left tail. And then finally the weight would be 6. Okay, symmetric. Typically you see that like that bell-shaped symmetric curve when you talk about weights in a population. Okay, there we go. The final thing we're going to do is look at some special types of means. And the first one is a weighted mean. Let's go back to blue here. There's a formula for it. Whoa, look at that formula. All right, we'll break it down. But really that's just saying multiply x's and w's, where w's are the weights, sum them up, and then divide by the sum of the weights. So I think a good way to tackle these problems is to make a little chart of x's and w's. And that way we organize the information well. The x's for this type of problem, we're talking about like a class overall score with weighted means. The x's are your scores, right? What you get. The weights are the percentage it's worth towards your grade. Okay, so for example, for tests, 50% are tests and you scored at 82, right? Those go together. So your score 82, weight 50. I don't know if I gave myself enough room over there. I might redo that. But thinking about as we go down, that's what we're really after there. Sorry, X, W, 82, 50. All right, the next type is the 15% for homework, and we got an 86 on that. The next one is 10% from quizzes. Our mean was a 50. Then we had 20% for the final exam, and we got an 80 on that. And then finally, the final project is 5%, and we got a 70. All right, so that organizes all that information. Now we're just going to follow that formula along, the x bar, mean. So that top piece, x times w, so 82 times 50. All right, just going to multiply all the pairs together. All right. One more. Okay, that's the top, right? Multiply your pairs, and on the bottom, it's the sum of the weights. So we're just going to add up all of just the weights on the bottom. There you go. All right, there's how that formula works. So make yourself a little table, multiply pairs, sum of the weights on the bottom, and then now it's just a calculation. This top number works out to be 7,840. The bottom number is 100. So our final answer is 78.4 overall average at the end. Okay. So there's a good example of a weighted mean. Another good example of a weighted mean is a grade point average, right? Like what's your overall GPA? You can do this in the same way, right? If we make a little table of X's and W's, just got to be careful which one's which. So in a grade point average, the system is an A is worth 4 points, B is 3, C is 2, etc. Okay? And then you also have a unit load per class, right? So the unit load is the weight, right? Like a 5-unit class is going to count more towards your GPA than a 1-unit class. Okay, so the point you earn is the X, the units or credits is the weight. So in this case, let's see, what did the student do? They got a B in a 1-credit class, or 1 credit or unit, however you want to say it. So a B is worth 3 points, and the weight is 1. Right? And then they got a D in a 3-credit class. The D is worth 1 point, and then 3 credits. So that's the B, that's the D. The C in a 5-credit class. C is worth 2 points, 5 credits. And then an A in, ooh, sneaky, A in 2 3-credit classes. So I gotta do that one twice. A is worth 4, and the weight is 3. But we had 2 of those classes. Right. So this was the report card. That's the breakdown. Once we have that information organized, it's a lot like the one we did above. Multiply all your pairs together. And then careful, divide by the sum of the weights. In this case, credits or units. I like units, but they sometimes say credits. Okay, there we go. Do the calculation. 40 divided by 15 is what it works out to be. This one said hundredth. Hundredth is 2 decimal places. 2.67. And that's that. Okay, so those are kind of fun and useful. Those weighted means come up quite a bit. Here's 2 good examples of, where you see it in a college. How about the last thing is a frequency distribution mean. It's kind of the same thing as what we've been doing. The formula looks a little different, but it's still sum of things multiplied divided by a total. Okay, so if you have a frequency distribution, you're going to have a range of values like classes, right? That's these things over here. And then you have frequencies, how many in each class. So this one is 30 small cars, mileage, find the mean. So the key to finding the mean is you're going to find the midpoints, right? Because what are you going to use for 29 to 33? You got to use something. So it's logical to just use the middle number. So if you find the midpoint of 29 to 33, that's 31. Like how we found midpoints in 2.1. That's 36. 41 and 46, right? Just the middle of the 2 values, or average them together, right? 44 plus 48 divided by 2. Okay, and then now you have it set up just like before. We have these are going to be our x's, the midpoints, and then we have our frequencies. So the structure will look just the same, right? You're going to multiply pairs. That, and then you're going to divide by the sum of the frequencies. 11 plus 12 plus 2 plus 5, or we already know that's 30, so we can just divide that by 30. It's the n, right, sample size. So sometimes you're given that, or if not, you just have to add up all those frequencies. All right, and we did it. Okay, so this is 1085. We calculate that top divided by 30. I'd verify that with your calculator, making sure you're getting the right values in your calculator, and that's about 36.2. All right, and that's that one. Okay, and then we're not going to move on to 2.4 in this video, so that's the end for now. Hope that was useful, and I will talk to you later. Thanks.